Okay, in this first video, we're going to run through the first four problems. Now, I didn't write out the entire problem. You've got it on your worksheet. I did draw out the diagrams that each problem has, and it's really important to analyze the diagram and enter in information. But make sure that you can read it, because sometimes the diagrams are so small you're squeezing numbers in, and then you can't read it after you've squeezed it in. So I tried to draw this out big enough so that everything can be seen here. And the first problem, right up here, this is a river. It says to find the distance AB, that's this distance there. Oops, here's A. AB, find this distance. 2 points B and C, 354 meters apart, are laid off on one side of the river, and it is found that angle B, which is this angle right here, I didn't mark this, did I? Doggone it. This is important. This is 112.2 degrees, and that the measure of angle C, which I did mark, is 15, looks like 15.3 degrees. My eyesight's getting worse. And we are to find the distance across the river, so we're to find D. Well, once you have two angles, you have all three. So hopefully you've tried this problem in advance, and the first step you did was to find this third angle right here. So I'm going to add 112.2 degrees and 15.3 degrees, and I'm going to get 572, I'm going to get 127.5 degrees, and then I'm going to take 180 degrees and I'm going to subtract that to find the missing angle there. And according to what I did the first time, I got 52.5 degrees. So that's this angle right here, 52.5 degrees. Now see, I have all three angles and I have one side. I can use the law of sines. Okay, you need at least two sides to use the law of cosines, and it's not a right angle, so it's not a right triangle, so you can't use SOHCAHTOA. So I know I have to use the law of sines. Now the reason that I went ahead and figured out this angle, angle A, is because the side opposite it was the only one whose measure was given, and I need a complete set of the angle on the side for a ratio. So I'm going to say the sine of 52.5 degrees divided by, hopefully you can see this okay, 354, that's a little darker, is equal to, now I'm trying to find this measurement D, which is between A and B. So the angle opposite is angle C here, 15.3. So I'm going to say the sine of 15.3 degrees divided by D, which is what I'm looking for. So I'm going to set up my proportion. I don't need this side. They're not asking for it, so you don't have to worry about that. It's not like you're solving the triangle. I cross multiply. I get D times the sine of 52.5 degrees is equal to 354 times the sine of 15.3 degrees. So if I divide both sides by the sine of 52.5 degrees, I'm going to get D is equal to, now you definitely need your calculator. When I did this on my calculator, I got 117.742. Now it looked like on most of his answers he's been around into two decimal places. He didn't indicate what it was. Now I did this and I got this. So I'm going to round to two decimal places, and I'm going to say that the distance across the lake across the river, I should say, is 117.74, don't forget your units here, meters. And put your answer down. Nice little law of sines story problem here. The drawing is what you need, because you're used to using the drawing to solving for sides and angles. So once you have the drawing from the story problem, then you can set up your ratios, whatever you need to, law of sines in this case. Now over here, if I'm not mistaken, this is another law of sines problem, because I see only one side given, and again, law of cosines, I need at least two sides given, and it's not a right triangle because there's no right angles. I mean, I can see that this is 80, so this is almost 100 here, 80.2, and then that's not going to be a right angle, so I'm using the law of sines on this one as well. And since I know this angle here, now let me read the problem. A rocket tracking facility has two radar stations at A and at B that are 1.69 miles apart. which lock onto the rocket and constantly transmit the angle of elevation to a computer. Find the distance from rocket A, from the rocket, let's try that. Find the distance to the rocket from A the moment the angles of elevations from the tracking stations are 29.3 degrees and 80.2 degrees. These are the angles of elevation, they're acute angles. So, I'm trying to find this side right here, and I think I just called it X, just to give it a name. You could call it lowercase letter b since it's opposite angle B. But not the 80.2 guy. These two form a straight line, so these two angles are a linear pair, and that means that they're supplementary. So I do 180 minus 80.2, and I get 99.8 degrees right there. So I need that guy, and of course once I have that guy, I need angle R because it's opposite the side that's given. So I add these two together, just like in the last problem, 29.3 degrees plus 90, here, let's put the plus sign here, plus 99.8 degrees, 1 carry 1, 9 carry 1, looks like 129.1 degrees, and then I subtract that from 180 degrees, and when I did this the first time, I got this to be 50.9 degrees. So that's this angle right here. I'm going to go ahead and label it 50.9 degrees. If I have everything labeled, and be neat here so that you don't make a mistake and think that the 9's a 7 or anything weird like that. So now I have everything I need because now I can use the law of cosines. I have a complete ratio. I have the angle the opposite side. So I'm going to say the sine of 50.9 degrees is to 1.69 miles as, now I'm trying to find x, so I use the angle opposite, that's this guy. So the sine of 99.8 degrees is to x. Now it's just like this problem. Only in this case I was solving for d, here I'm solving for x. So you cross multiply, I get x times the sine of 50.9 degrees is equal to, multiply this way, 1.69 times the sine of 99.8 degrees. And I'm going to divide both sides by the sine of 50.9 degrees. Make sure your calculator's on degrees, 50.9 degrees. And I get x is equal to, and again, I got my calculator out earlier, and I got this to be about 2.1459. So I rounded it to 2 decimal places, and I said that the distance from point A to the rocket is 2.14 miles. Actually 2.15 miles. Okay? Next guy up. This is kind of a weird one. It says a civic group plans to landscape a lot that is located where a road forks and forms an angle of 62 degrees. Oh, 62. I think I just wrote 52 here. 62 degrees. Gotta make sure I write it down right. If the frontages on the road on the lot are 125.5 feet and 90.8 feet, did I get that right? Yes, I did. Find the area to the nearest whole square foot. So to the nearest whole square foot, I'm rounding to the nearest one, or to the nearest unit. So in this case, I have 2 sides and the included angle. Now if I had all 3 sides and no angles, I'm using Heron's formula. But in this case, I can find the area by 1/2 times one side, 90.8, times the other side, 125.5, times the sine of the angle that's in between the 2 sides, the sine of the included angle, so that'd be the sine of 62 degrees. So I just punched this out on a calculator, and I got 5030.77 square feet. So to the nearest whole square foot, the area is 5,031 square feet. Don't forget your units. Okay? These are story problems. Write your answer out in a short sentence. All right, the next problem here, it says to determine the distance across lake from A to B here, that's with a dotted line. Okay, a surveyor goes to point C. Now my picture doesn't look exactly like the one on your worksheet, but it's close enough. where he can measure the distance from C to A, and he measures the distance from C to B as well, and he measures this angle right here, angle ACB. He says this side is 265 feet. Now, they didn't label that in the diagram. You got to, that's why you use the picture and you draw it all in. And then BC, that's from here to here, is 188 feet. And the angle is 42.3 degrees. And it says here, find the distance AB across the lake. Now look what you have. You're trying to find this. Side, angle, sides. Not a right triangle. You have two sides, the included angle. You got to use the law of cosines. So that would be x squared. All right, the side in question is equal to the one side squared, 265 squared, plus the other side squared, 188 squared, minus 2 times the first side, 265, times the second side, 188, times the cosine of the included angle, 42.3 degrees. So I got my calculator out, and I did a bunch of this, and I got this to be 31,872.1577. I went ahead and took it out 4 places because this isn't my answer. This is just getting me to my answer. My answer is going to be the square root. I have to take the square root of both sides. So I get this to be 178.5277. So x is the distance across the lake. It says find the distance AB across the lake. The distance across the lake is 100, let's get it a little bit so you can see it, 178 point, looks like 53, and my units are in feet. And that's how the first 4 problems work. Pretty straightforward stuff. Now they get a little trickier on the back, but that's how the first 4 go. So hopefully you tried these in advance, and hopefully you figured out if you did anything wrong, what was going on with it. Because I'm going to guess if he's going to have a quiz with 8 problems on the first topics that he didn't give you, then he's probably going to have at least 8 problems on those topics and probably a couple more out of here, minimum. So he might have a 10 problem test, I don't know, maybe I'll have a 20 problem test. But you got to practice these, so we're going to go on to the other 4 problems that are on the back.